We're going to be talking about the trend line a bit more today. We're going to be calculating the trend line. How do we do that in the calculator? I'll remind you that process. We're going to be talking about residuals as well today. So a trend line is the line that estimates the data from a scatter plot. What happens if you can't tell which trend line represents the data? Then we analyze the vertical deviations. Between the actual points and the line. Again, so as we're looking at it, and sometimes we got to, try to figure out, hey, what is that best line that's there? And we're looking at the vertical deviations between the points and that line. And our goal, when we look at the definition coming up, the least squares regression line, the least squares regression line is the line that minimizes the sum of all squared residuals. Now, residual is a new term. We haven't talked about that before. So we square the deviations and then add those values together. And then the line with the lowest sum is called the least squares regression line. We are going to be referring that to as the LSRL, is what we get to refer to it as. What was that in our older days when we were younger in math? That was the line of best fit. Okay, that's what we referred to it as. Okay, so the least squares regression line is the formal name for it. As you guys were younger, we just, instead of saying that and telling you how you come about getting the exact one, we just called the line of best fit. It best fit the data based on using some real approximating skills. Now we're being more specific, calculating these residuals, squaring the residuals and adding them up and so forth. And so that's why it's called the least squares regression line. Now, what is a residual? The residual is the distance between an actual point and the regression line. So as I highlight this very top point up here, this vertical distance is what we call our residual. It is the difference between the actual value and the predicted. So this happens to be the actual, the very top point. Any point on the line of best fit or the least squares regression line, that is a prediction. So we use that line to predict stuff, to see if it occurring, if certain events happen. What's the prediction for how much weight they can carry if they are 145 pounds? What would that line predict? Because again, as I look quickly at that graph, there is no dot that goes, if you went over to 145 and went straight up, there's no red dot there, so we don't have an actual. So we're just trying to get, can we predict roughly what a 145-pound weight person could carry for a backpack? We're going to talk about, what happens when the residual is a positive number, what happens when it's a negative number. That's what we're going to address here in a little bit. So with our calculator, what we can go through is we can put our information into L1 and L2. We put the explanatory variables into list 1, our response variables into list 2. We then press stat, calculate. We go down, and basically the first option here is option 4. And the second option that's listed there is option 8. Now, in format, they prefer in the AP stats world to have the y-intercept written first. Okay, so if you use option 8 and get in the habit of using option 8, then we have it when we pull the numbers out of it. We got it in the right setup to write it down as an equation as we write the equation. Both of them will give you the exact same calculation. It's just a formatting. I always try to do option 8. That way I know it's set up the way they want it written as a free response answer, or how it's going to be as a multiple choice. Now, after we have to do that first. We have to create that line of best fit first. Once that is done, then we go back in, and we create all that stuff done. Boom, 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 boom. Oh, we'll stop right there. I was saying too much. So that's the steps on how to do it. We're going to practice it with a couple things here. It not only will it give us the slope and y-intercept for our problem, it's also going to give us It's going to do the R value. It's going to do that, and we did that in yesterday's lesson, how to do it by hand. And then that's technically supposed to be, and I got to go back and edit this Word doc, that's R squared is what that second one's supposed to be. It's not supposed to be R subscript. It's supposed to be R squared is what that's supposed to be. And again, we get to talk later about what R squared is, the coefficient of determination. What does that mean? The R is our correlation coefficient. That's what we had in our lesson yesterday. We can, if we want to, when we do the process, as we do this lin reg, you can tell in the process for it to store the equation in one of the lines like Y1, Y2, Y3, and I'll show you how to do that. That way you don't have to retype it in. You can actually tell it as it does the process. You can get it to calculate the information, put it into Y1 so you don't have to hand key it. And then we can go from there. So we'll walk you through on that process. The regression lines are usually written in the form, and here's the fancy way, and Y hat equals B sub O plus B sub 1 X. And then again, we define what B sub O or B naught is. B naught is the y-intercept. And then B sub 1 is your slope or your rate of change. And again, we have to be able to interpret in context what the y-intercept means and what the slope means. Again, y-intercept is always as the explanatory variable is 0. This is what the response variable is as a value. When we interpret the slope, we want to make sure we talk about that the response variable, whatever it is, and what amount it changes for every increase in one of the explanatory variables. Be very careful, and I think we have an example coming up here in a minute, where they don't do it, it's actually the units for the explanatory is in thousands. So we want to make sure, as we say, for every 1,000 of something. So make sure we use, if something's more than just a flat out 1, we need to make sure that we tag on the units for the different place values. So here is a problem, and again, I'm going to do a split screen here, and we're going to go through and type this stuff in. We can go ahead and type in the numbers the way we see it. Don't worry about doing like 22 and 3 zeros. Just type it in as 22. Okay, don't as we do that. So I'm going to go in here, do a split screen. I'm going to bring up the TI-84, and let's go ahead and enter this stuff into L1 and L2. L1 is going to be the miles driven. L2 is going to be the response variable. So it's going to be the cost in dollars. TI-84 calc. Eventually, I'll catch up to you. Stat group. That. There we go. Now, just make sure you're careful. We got to make sure we have nice. We're careful on our data. We got to make sure we pair up the X value with the corresponding Y value. You switch them around, then you're totally getting something different, a totally different equation. So hopefully I'm able to type this in there correctly as I'm talking, and we get the same answer when it's all said and done. All right, it looks like I got the same number of items, which is good. Anytime you do what we're getting ready to do with the linear regression, if you get an error that says like dimension error, that usually means that you don't have the same number of X and Y values in there, and there's a mismatch. And so you just want to go back in, double check it to see what's going on. Now, all of our data is in there. Before we go any further, what I want to do is we do have to be able to find the the R value, the correlation coefficient. And typically, whenever our calculators are reset, the feature that displays it is usually turned off. So before we go in here and do our LinReg feature, let's make sure that the R value thing is turned on. And so what I want you to do is press mode, and then you're going to go down to where it says stat diagnostic. And whenever you reset a calculator, it's always defaulted to off. So we need to make sure the stat diagnostic is turned on. And again, that'll allow us to see the R value and the R squared value. That way we don't have to calculate it by hand like we saw yesterday. Okay. Now that I turned on my stat diagnostic, we're going to press stat, arrow over to calculate. I'm going to go down to option number 8, or you can just press the number 8, press enter. You make sure that you have your L value, where are your L1, where did you put the X values? We put them in L1, Y in L2, so it's set up right. That store reg EQ is where I can tell the calculator to put the equation of Y hat equals, put that into Y1, Y2. That way when I want to look at the scatter plot and I want to look at the line, the LSRL, it'll already be there for me. I don't have to retype it. So let's go in here as we do store reg EQ, press the green button alpha, and then press trace. And that's going to give you the menu of shortcuts of all the different functions for graphing. I'm just going to use option 1, Y1. So I'm telling this thing to put the equation with an X in it, with the Y-intercept and the slope, put it into Y1 when it's all said and done, so I don't have to key it in by hand. Okay? It also helps speeds up when we get to do applications with the function. I'm going to go down to calculate, hit enter, and there's my information. Notice it gives me the format of Y equals A plus BX. When I go to write, what is the correlation, interpret the slope in context. Do they ask us on one of them to write I got to write the equation. So with that in mind, equation-wise, I'm going to write down at the bottom. Oh, come on, you little turkey bird. I hate it when it gets in that little funky mood where it doesn't want to do stuff. So as I write this, Y hat equals, my Y-intercept is 18,773. Again, the calculator is going to take all those decimals. So when it puts it into Y1, it's going to use all of those decimals. Since it's money, it is okay to cap this thing off at the nearest penny. Is okay to do. Our slope is negative, so negative 86.18. Again, the more decimals we use, the more accurate it becomes. Yes, sweetheart?
I got to the number 8, but I don't know how to do the Y1 part. So.
All right, so are you on the store reg EQ?
Yeah.
Press the alpha button, green, and then press trace, or press trace. And then choose, you'll see, and then press enter. And that way it'll put Y1 there, then go down to calculate. Okay? And so 0.8618, slap on an X. So there's my line of best fit. We're going to go answer some of those questions. As you do these things, you need to make sure when you write the equation, you define what the variable stands for. So you need to make sure on a free response, you define what Y hat is and what X is. Y hat is our predicted price. It's our predicted price. If you just say price, they're going to count it wrong. It is our predicted price is what Y hat is. And our X value is mileage. And it's in the thousands. Again, if we leave off that units and just say mileage, they're going to mark it off if we, as we go through it, because again, we've abbreviated and didn't include the thousand, so 000, as we're putting numbers in there. So we have our equation, we have our variables defined. We have to do that for every free response question when we answer it. Now we're going to go up and answer these questions. Use the calculator to find the equation of the line of regression line. We did. What is the correlation? Our correlation, according to the calculator, R equals negative 0.8743. Again, we're going to go out 4 decimals on the R value. Yes.
I was having trouble with the computer, getting the R squared and the R.
Okay, so press mode. Arrow down to stat diagnostic. Toggle over to on and press enter. And then now do second mode to quit the screen. And then do a WinRig again and it'll pop up. Okay. All right, so what is part B? Says what is the equation, and then in context. Well, I already wrote the equation. So what does it mean in context? What we're going to talk about here is the price or the cost. So as I try to zoom in, do I need that anymore? No, I don't need that. So let me get rid of that screen of the calculator. The Oh, and you know what? Never mind. This stuff right here, that's going to be my answer. That's that part right there. So, my bad. So there's that. We just didn't have enough room in there. I didn't leave enough spaces. The part B part, interpret the slope in context. So as we look at our slope is a negative 86.18. So the cost changes, or we can say decreased. We can say the cost decreased by $86.18, and I can put the dollar sign there for every increase in 1,000 miles driven. Again, you know, we didn't type it in as 22,000. So as we talk about, for every 1 increase in the explanatory variable, we have to tag on the 1,000. So we get to say either for every 1,000, doing the 1,000, or we can do 1 and then write the word 1,000 miles driven. So there is the interpreting the slope in context. The cost or the price of the car decreases by $86.18 for every 1,000 miles increase driven. Part C asks us to interpret the y-intercept. Again, our y-intercept was the 18,000. So we would say when the car has 0 miles driven, it will cost $18,773.28. So there's our interpretation of the y-intercept. Give you a chance to copy that down. I'm going to ask you the question. Do we have any questions about that? I'm going to find a nice little... I need a bigger board. I don't think Mr. Powell let me paint the wall white up above that. It would look good though. What if I get the art department to paint it white and put some like Buccaneer logo stuff on the outsides of it? Don't think so. I think it would look good. But again, Mrs. Ridgel has outside the art room, she has that beautiful mural she did.
She's the art teacher. My main concern is just the next teacher that's going to have this room.
We don't have to worry about that. That's 5 years from now. Who cares? And he'll probably be retired by then. Do what?
And get another the screen. Does it mean is that we would just another screen on our side? Or?
Yeah, there is a screen I found, but it's a matter of re-rigging the stuff because the mechanism's broken. So, all right. Next part, predicting from a line of a regression line. The purpose of having a regression line is to be able to predict the response variable. So we're trying to predict the response value. Might be with a certain, basically predicting it what it might be with a certain explanatory variable value. That is why we use the hat on top of the y instead of a y, because y stands for the actual value in a scatter plot, whereas y hat, okay, so y is the actual value in the scatter plot, whereas y hat, got to put a little hat on there for me, which is pronounced y hat, is the predicted value. Based on the regression line. So you have to make sure you put the symbol on there for the prediction amount when you go to put the x value back in to find out what did it predict it would be. The difference between the actual minus the predicted, which we can see as y minus y hat, is how we would show symbolically. That is called the residual. So as we mentioned up earlier in the notes about the residual was the vertical distance between the actual red dot on the very first picture and the blue line. And so, and each dot actually has a residual. Some are large, some are small. The smaller the residual, the closer you are to the prediction line, which means the prediction was not off by much. The bigger the difference, then that tells us that the predicted value is quite a ways away from the actual value. But again, the difference is called the residual. And so they want us to go through here on the previous problem, and using the equation that we have, they want us to predict the price of a car from 49,000 mile and compare that to the actual. So with that in mind, we do have up above for a car that had 49,000 miles, it actually had a price of $14,988. $14,988. So that was the actual price of the car in the data. Now, we are curious, what did the y hat equation predict for a 49,000 mile driven car? Okay. Now, we're going to put 49 in there. We're not going to put in 49 with 3 zeros because, again, when we did our equation, we didn't put in the extra zeros. Okay. So we do not want to add those because then it's going to be really crazy of an answer. So we got to go in here and look for the predicted amount. So as we look at our equation, what is 18,773.28 minus 8618 times 49? So I need to figure out what did it predict that to be? And again, we can go in, put it into our equation, and do it by hand. I'm going to show you another way on the calculator to go about doing it to make it faster. Did you get something like this? Did you get something around 14,550.36? Did you get that as the amount when you actually typed in 18,000 minus 86.18 and then the 86.18 times 49? Did you get about that? And I'm going to split screen and bring my calculator back up on my screen. So again, oh stinkers. So 18,773.28 minus 86.18, and that's being times 49. There's our answer there. So that's about what we got. Now there's another way, and this is what helpful about using the store the equation into y1, Because if we press Y1 right now, if we press Y equals, we'll notice it put an equation in for Y1. Now, it used a lot more decimals, which means if we use that equation with the 49, it's going to be a little bit different than what we have already because it went out more decimal places. It went out more accurate. Okay? So I'm going to hit second quit. And this is the nice feature when you store an equation at any time in for one of the Y1s or whatever. If I press alpha trace and press enter on Y1, and then I do parentheses 49, so what I'm telling the calculator to do is take the Y1 equation, put 49 in for the X. That's what I'm telling the calculator to do. And when I press enter, it goes ahead and does the calculation for me to where I don't have to key in these things. Now, it's a little bit different than we got, and the reason why it's a little bit different, and it's not by much, it just went out a couple extra decimal places, but it still rounds to 36 cents as to the nearest penny, is what it rounds to. Whereas when we use the rounded version up above at the 100th place value, notice it was 46 cents. So there is a difference. And again, we take things out to 4 decimals as we do calculations, and then we round to the place value. So it would have been more appropriate to do this one using all 4 decimals and then rounding to the nearest penny, because we're always supposed to round to the nearest whatever after the last calculation is done. So if I wanted to find the residual, for this amount, I would do the actual, I would do the actual minus the predicted. So that would be, the actual was 14,988 minus 14,550.36. And, what is that difference? And that difference is a positive 437.64. So that's what my residual is. And then we get to talk about, well, was that amount an over prediction or an under prediction? And technically, this would be an under prediction. Now, we get to talk about that a little bit more in depth here in a little bit in the lesson. This under predicted what it was. Because again, 14,500 is less than 14,900. So it under predicted is what our line did. It under predicted the amount. Not off by much, but it did under predict it. Here's a vocab word that comes up where it's new to a lot of us, extrapolation. Extrapolation occurs when you use the regression line to predict a value outside the domain, the data's domain, or the X values. If you only have data for an explanatory from 10 to 50, you cannot predict a value lower than 10 or higher than 50. Since we don't know the behavior of the data. We don't know, do not know, or don't know. Don't know the behavior of the data outside the domain. We take a huge risk of trying to make predictions outside those values. Okay? And they had an example for us to do here of saying, okay, what if we use that equation and we did it for a Honda car that had 250,000 miles driven? So they're saying, what happens, what would be my predicted amount? So we know 250,000 is outside of our range, because if I go back up here, I'm only dealing with 86,000, looks like the most amount of cars driven. 250,000 is way outside that domain. And so they're telling us, hey, it would be in a form of extrapolation if I did this. Now, real quickly, I'm going to go through and figure out, well, what does that mean for the price of the car in the context of the problem? So if I go in here and say alpha trace, let me use Y1, and I'm going to put 250 in there, and I hit enter, notice what it tells me what the predicted price of the car will be. It says the predicted price of the car is $2,772.27. All right. So does that make sense? Hey, I'm going to pay you or you're going to pay me $2,700 for me to take that car that is 25, as you're trying to get rid of it. I'm not buying it. You're going to pay me to take it off your hands. Okay? So that's why we don't use X values or domain values outside of the data range with the predicted equation. If we do, it's a form of extrapolation. So that typically shows up on free response questions on the AP exam with regression stuff. Now, a residual of the least squares regression line is the difference between the observed and the predicted. A negative residual means we've overestimated. A negative means it's overestimated, which means that the actual value is below the prediction line. Okay? So when you have a negative residual, that means the actual value was below the LSRL, so is below that line of best fit, and that ends up being a overestimate is what that means as a residual. If it's a positive residual, that means we underestimated. It means it underestimated the response value. And again, in that previous example, not the 250,000 miles, but the one before that, we found out that it was like it underpredicted by $400, which is not a bad thing, but for somebody that had their heart set on a certain car, and they were using that thing to figure out that equation line to decide, hey, do I have enough money? Hey, I got $14,500 or $14,600, and I go in there and then, hey, it's actually worth this much or so forth. So here is an example where they have the data for sprint time and long jump distance. Sprint time was the explanatory. So that went into L1. The response variable was the long jump distance. They came up with this equation of the least squares regression line for the sprint time and long jump distance. And then they said, find and interpret the residual for the student who had a sprint time of 8.09 seconds. So what we need to go through is we need to figure out, okay, first, we know where 8.09 is. Here is the actual. So that's the actual part. And so I need to figure out what is the predicted. What was the predicted amount for 8.09 seconds for that equation? So what is 304.56 minus 27.63 times 8.09? And I got to figure out what is that value, okay? And when we do the 27.63 times 8.09 and subtract that from 304.56, we should get approximately 81.033 is what we should get, okay? Now, as I look at the residual, the residual is the actual. The actual was 151. Subtract off the prediction, 81.033. And then I find out, okay, what does that work out to be? That works out to be 69.666 repeating. And then now we have to answer the question, was it an overestimate? Was it an underestimate? It's positive, so it's a what? It's a positive amount. Positive means an underestimate. Okay, positive means an underestimate. So it underestimated. So the LSRL underestimated the long jump distance and again underestimated the long jump distance by 69.667 and units was inches. Now, what's 69 inches roughly? 5'9"? right? 60 inches is 5 feet. So with that in mind, you're almost, almost 6 foot. So you take a person that's 6 foot, that's how far it basically did it. I'm 5'10", so you can take me. My height is what it under predicted it by. That's quite a big deal. I mean, that's a lot when you look at a competition that it underestimated, especially if somebody was using that to train for something, okay? When calculating the regression with means and standard deviation, we have used technology to find the least squares regression line, but we can also find it with using means and standard deviations and their correlations. So that's the by hand version, is what this is talking about. This is the by hand. Now, you will be expected on the AP exam to be able to do it by hand, and they won't give you a set of data. They'll just give you the information. Okay, and that's what this part is containing to. They give you the formulas on the reference sheet. So it's a matter of saying, hey, I need to grab this and put it in these formulas to create not only to create the line of best fit or the regression line. Okay, so again, our equation y hat is equal to b sub o plus b sub 1x. That's our equation. That is the same format that it is on that formula sheet that they give us on the AP exam. Now, they're going to tell us what the mean is. They're going to tell us what the standard deviation of the x is. Now, here's the thing is they're going to tell us the mean of the x variable, the standard deviation of the x. They're going to tell us what the standard deviation of the y, the response variable, and the standard mean and standard deviation of those. And then they're going to tell us the correlation. So in order to do this process that I'm getting ready to show you, they have to give you if they don't give you all the data values, they have to give you the mean of the response and explanatory variables, also their standard deviations, and they need to give us the correlation. The R value is what they have to go through and do. Now, here is how you would compute the slope. And we're going to talk about what we do in which order first. The slope, B1, is equal to the R value times the standard deviation of y divided by the standard deviation of x. That's how we calculate the slope. Back when you guys are in 8th grade, we just had you fold the line on the during the scatter plot, pick 2 points close to that line, find the slope y2 minus y1. Technically, statistically, we're supposed to take the standard deviation of the y values divided by the standard deviation of the x values, multiply it by the correlation coefficient, and that's the slope. To find the y-intercept, which again was b sub 0 or b naught, that is equal to the mean of the y values, subtract from it the slope that we just found times the mean of the x values. And that's how I calculate the y-intercept. Again, we're going to get a chance to practice that by hand here in a minute, because that will show up on the AP exam in a free response or maybe a subpart of on the free response is a subpart or a multiple choice question. Now, all least squares regression lines will go through the point of x bar minus y bar. All regression lines will go through the ordered pair, the x mean, comma, the y mean. Let's see how much we get through today. So let's practice it. So it says used Hondas, the number of miles in thousands for 11 used Hondas has a mean. So this is because again, we said miles was X and price was Y, because we said miles, the miles driven was the explanatory. So X, I'm going to just write down here, X bar is equal to 50.5. The standard deviation, so S sub X, was equal to 19.3. The asking price, which was the response variable, has a mean, so Y bar is equal to 14,425. And then the standard deviation of the y's was 18,999. Sorry, 1899, sorry. And then they tell us the correlation, the R value, is equal to negative 0.874. And then they asked us to figure out what is the equation of the least squares regression line. So they asked us to come up with that y hat equation. Again, y hat equals b sub o minus or plus, I guess it doesn't really matter, plus b sub 1 times x. And again, b sub o, how do we find b sub o? That was x, sorry, y bar minus the slope times x bar. And then the b sub 1 was the r value times s sub y over s sub x. How did I do? I did pretty good on memorizing that. All right, so again, what we would do first, we need to find the slope first. So the first thing we got to do is find slope. Because we can't find the y-intercept unless we have the slope. So we got to find the slope first, is what we got to do. So with that in mind, b sub 1 would be equal to negative 0.874 times 1899 over 50.5. Now that part just becomes a calculator activity, okay? This is what I got for the slope, b sub 1, is 85.996 by doing that out, okay? Now, is it a negative or a positive? And how do we know? You still with me? Oh, it should be 19.3. I was looking at the wrong line. Thank you, sweetheart. Sorry, my bad. My bad. I appreciate you catching that. 19.3. I was looking at the wrong line. That works out better. But again, is the answer negative or positive? It's negative, right? If I have a negative 0.874 times the fraction, and that fraction will always be positive, what's a negative times a positive? Negative. So it's going to be a negative answer. All right? Now I need to go over and figure out the y-intercept. So that's my second step. Find y-intercept. Find y-intercept. So my b sub naught is equal to y, the mean of the y. So 14,425 minus negative 85.996 times now I get to use the 50.5. And then my B naught, we should get something about like this, 18,794.798. And, you know, again, it's okay to leave it that many decimals. And then when I go to write the equation, I would say y hat equals 18,794.798 minus 859 or 0.996 x. And then we would want to make sure that we define what y bar and or y hat and x are. Again, you'll have these formulas will be on the cheat sheet. When we do our test, it'll be on there. You'll be able to use that. AP exam, same way. It's tedious. And then they asked us to explain what change in price we would expect for each additional 19.3 thousand miles driven. So we would write some little statement right here. Well, first off, so for each additional 19,000 miles driven. So what is negative 85.996 times 19.3? That works out to be that decimal, negative 1.6597228. And again, the slope was technically for every 1,000. It would decrease it decreased $85 or $86 for every 1,000. They're asking us for every 19,000 miles driven, what is it going to decrease by? Not just 1,000, but 19,000 miles driven. So that's why we got to multiply what we have, the slope times the 19,000 or the 19.3, and then we would go through, say that the price will drop $1,659.72 for each 19.3 thousand miles driven. Again, sometimes we're just asked to interpret the slope. Here we're asking, using the slope, and instead of every 1,000 units, every 19,000 units. Now, not sure why they put 19,300 miles. I think there's some statistics out there that most people on average drive somewhere close to 20,000 miles a year, roughly, on a car. Some are less, some are more. Okay. I think when I had my mowing business, I was driving somewhere close to 25 to 30,000 miles, just doing all the, not only driving to school, but going to the different houses and yards when I was doing 80 yards a week. And then I'd have my summer trip by going up to Canada. Now that all I do is drive from home to school and typically back home, maybe hit the grocery store on the way home. Instead of me filling up my truck twice a week, now I'm going every 2 weeks to fill up my truck. Okay, so I get roughly 400 miles, 5 to 450 per tank load. So, I'm driving a heck of a lot less now than before. I even think about my daughters when they were going to school in Lipscomb, and they only lived maybe 5 or 6 miles away from campus. And so I would change their oil at Christmas time, and then when they came home at the summer, which was technically months past when you're supposed to do it, they say every 3 months, they still hadn't even hit 3,000 miles in 6 months and stuff. So they never drove that much. So, but I think that's where they got that 19,000, trying to equate, if you drive it roughly an extra year, how much is it going to decrease? I think is what they're kind of interpreting that to be. What happens if we standardize both variables? So again, we talked about z-scores. Remember, we can standardize by changing the values to z-scores. So what would the equation look like, and so forth? That's what this is talking about. Remember, z-scores, our mean will be 0, our standard deviation of 1. The slope, this is what the slope will actually look like. When I go to calculate B1, it is going to be equal to R times 1 over 1. And again, the reason is because both the X and the Y have a standard deviation of 1. If we convert them to C-scores, S sub Y is going to be equal to 1, and S sub X is going to be equal to 1. And so the slope is going to be whatever our R value is. That's what the slope's going to end up being, the correlation coefficient. The y-intercept, which is the next one, the y-intercept, which is B naught, that is going to be basically, okay, if the mean of y X mean is 0 and Y mean is 0, we're going to have basically 0 minus 1, the slope, or sorry, R. 0 minus R, and then times 0, which is going to be 0. So our y-intercept is just going to be, our b sub naught is just going to be 0, is what it's going to end up being. And so when I look at the final z-score equation, for the z-score equation here, it's going to be y hat equals 0 plus whatever r, of rx is what it's going to be. So r of x kind of may look a little bit crazy there. Let's just do that as an x. So it's going to be rx. So whatever your correlation coefficient is times whatever x value you're using, that's what our predicted amount will be. We won't have to worry about a slope to put it, or a y-intercept to add or subtract the thing from. We're doing good. I know this is a lot. This is going to be split up, and we're going to have to finish this up tomorrow as we go through, which means I'll extend our homework because I still have roughly about 2.5 front and back of 2 pages in the third one. So so I'll extend homework. Try to chip away some of it tonight, and then we'll finish up tomorrow too. But we'll finish up notes tomorrow too. Next part is the line of best choice. Is the line of best choice for your data? We look at a residual plot, and again, our key thing here, if we're deciding that is it our line of best choice, we're trying to decide, is it linear? And we use a residual plot to help us figure that out. A careful look at the residuals can reveal many potential problems. To assess the appropriateness of the regression line, a residual plot is a good place to start. Now, what is a residual plot? Well, a residual plot is a scatter plot of the pairs, and it's the pairs of the x value, comma, the residual amount. So as we calculate the residual for each of the things, predicted or actual minus predicted, a residual plot, and that's what this second one is. This second one is a residual plot. The second picture here is a residual plot. It is a horizontal line that's drawn. That way the x values are the horizontal line, and the y value represents the difference, is the residual part. And so we can see how far and up, above, and below. And then we have to use that to decide, is it appropriate for what I see on the left-hand side? Is my linear approach, is it appropriate? The sum of the residuals is always 0. If you add up all of the residuals, the sum is 0. Okay, yes?
Under the residual plot, it says X, what's that subscript? Is it just 2 or is it
On the picture that they have there?
No. Like on the right side it says a residual plot. It's a scatter plot.
Oh, that's a comma.
Oh, okay.
It does look like a subscript. That's a comma. It almost looks like a G. Yeah, that's a comma. So a residual plot is created, it's a different type of a scatter plot, but it actually is the x values, so L1, and then we would calculate the residuals, doing each actual value subtracted by the predicted and so forth, and get those amounts. And I'm going to show you how to get the calculator to do it all for you. Okay? It does it in a nice, short, sweet kind of process. As we look at the next one, here is the picture on the left-hand side. Here's the original scatter plot. So this was the original scatter plot.